said, this is super similar to 3-2. We're going to be, it's pretty much the opposite. So 3-2, we use parallel lines to find the relationship between different angles. Now we're going to be using the relationships of different angles to prove that lines are parallel. So we're not really doing the opposite of what we did. But a lot of the information is the same. It's almost just thinking backwards. Okay? So, in the past, we found slopes of lines and used them to identify parallel and perpendicular lines. Now, what we're going to do is recognize angle pairs that occur in parallel lines, and then prove that two lines are parallel using those angle pairs. Now, you might be like, Mr. Selby, why would I ever need to do this? Well, you may not have to recognize angle pairs in real life, but now that we've learned what angle pairs are, you're able to think backwards. It's all the time. You gotta think backwards all the time. If you know something's right, and then you gotta explain why. You gotta explain it backwards. That's essentially what we're doing. This is just a good skill to have. A good way to be able to think going forward. All right, so let's keep going with it. So, converse and corresponding angles postulate. If two lines are cut by a transversal, so the corresponding angles are congruent, and the lines are parallel. So, angle 1 is congruent to angle 3. Angle 2 is congruent to angle 4. Angle 5 is congruent to angle 7. Angle 6 is congruent to angle 8. Okay, line A is parallel to line. So essentially what it's saying here is, so you know the corresponding angles postulate. You have two parallel lines cut by a transversal, their corresponding angles are congruent. So 1 and 3 are congruent. This is saying the complete opposite. If two corresponding angles are cut by transversal, that means the two lines that they're on are parallel. Okay? It's literally just saying the same thing backwards. Right? Parallel postulate, this one can be a little bit confusing, but I think it's always great to demonstrate it. If given a line and point not on that line there, then there exists exactly one line where the point is parallel to the line. So if you draw a line, right, and then you put a point somewhere outside of the line, the only way that that line is going to be, the only way that you can draw a parallel line that goes through that point, there's only one. There's only one way to do it. No other parallel line would go through that point. Alright, so these are very similar to the corresponding angles converse, okay? Alternate exterior angles converse, the consecutive interior angles converse, alternate interior angles converse, and the perpendicular transversal converse. Okay, these are literally the same thing as what we did in the past, okay? But it's saying that if the alternate exterior angles are equal, the lines are parallel. If the consecutive interior angles are supplementary, the lines are parallel. The alternate interior angles are congruent, the lines are parallel. If it makes two right angles, they're parallel. Right? It's pretty much just saying the converse of what we've already learned. Remember, the converse is just saying something backwards. It's like saying Mr. Selby is the best teacher, the best teacher is Mr. Selby. Both those statements could be considered true. So, given angle 1 is congruent to angle 3, is it possible to prove that any of the lines shown are parallel? Yes, so it's the postulate or theorem that just does it. So, angle 1 and angle 3 are corresponding angles. So, since angle 1 and angle 3 are corresponding angles are congruent, that means A and B, because their corresponding angles are congruent, are parallel by the converse of corresponding angles postulate. Also, what did we say? Pretty much the opposite of that would be if A and B are parallel, 1 and 3 would be congruent because they're corresponding angles. Alright, given the measure of angle 1 is 103 and the measure of angle 4 is 100, is it possible to prove that any of the lines shown are parallel? If so, state the postulate of the theorem that justifies your answer. Okay, so what we've got here is 1 and we've got 4. So the only ones that we're concerned about is A and C. Okay? Don't forget the nexus. In this case, they would be alternate interior angles, right? And if they're congruent, then its lines are parallel. Clearly, they're not congruent 103 and 100. So they're not congruent, the lines must not be parallel. And as you can see, C comes from the same things. So that's check your progress. So, given that angle 1 is congruent to angle 5, is it possible to prove that any of the lines shown are parallel? Would you guys take a second, pause the video, and think about this? If you're doing this, maybe backtrack a little bit, come up with the correct answer, be very smart. Excellent. Okay. stop talking for about 5 seconds. All right. Hopefully everybody paused it and was able to come out with the right answer. Let's see, what is the right answer? Yes, L is parallel to N. All right. You should not have had M in any of these because 5 and 1 don't even touch M. So, also, these are corresponding angles. 1 and 5 are corresponding angles. And if they're congruent, that means that their lines that they're on are parallel. So L and N are both parallel. Given, measure of angle 4 is 105 degrees. Measure of angle 5 is 70 degrees. Is it possible to prove that angle and should be parallel? I'm going to stop talking for about 5 to 10 seconds. You guys can also be talk about this. Keep with the right answer, and we're correct. Okay, hopefully you were able to solve this. Come up with the right answer. All right. It is unfortunately not possible to prove any of these. So if you look at this, you say 105 and 70. So they're consecutive interior angles, right? So they would have to be supplementary. So if you have 105 and 70, do you get 180? No, you get 175. That's tricky. So you get 175, which means they're not supplementary, which means these lines are non-parallel. They lose. Standardized test example number 2. Find the measure of angle ZYN so that PQ is parallel to MN. All right, show you what. So ZYN is right here, 7x plus 35. So it would have to be, for these two lines to be parallel, it would have to be equal to 11x plus 25. So we'd have to set them equal to each other and solve for x. So let's figure that they're equal because they're also exterior angles. All right, for them to be parallel, they have to be equal. Substitute the given angle measures in this equation. So for x, once you have value of x, you substitution of x. Essentially, just what Mr. Selby said. 1, 2, 3 plus this. So alternate exterior angles. Substitution. Subtract 7x from both sides. You get 4x minus 25 equals 35. Add 25 to both sides. 4x equals 60. X equals 15. We need to divide by 4 on both sides. Now, use the value of x to find ZYN. We know x equals 15, so plug it in. 7x plus 35 is the same thing as 7 times 15 plus 35. Right? 7 times 15 equals 100. Equals 105. Plus 35 is going to be 140. Answer. Measure of ZYN is 140 degrees. Verify the angle measure by using the value of x to find the measure of wx. X, wx, wx. 11x minus 25 is the same thing as 11 times 15 minus 25. 11 times 15 is 165 minus 25 is 140. Wow, it's the same thing. It works. All right, since they're all equal, PQ and MN must be parallel. All right. Now it's your turn. Solve this. I'm going to stop talking for about 5 to 10 seconds. If you guys can just take this time to solve this one. That'd be phenomenal. All right, hopefully you're able to solve this one on your own. Hopefully you pause it while Mr. Selby is speaking so that you can solve it. And hopefully you know the answer. If you don't, you can pause right now because I'm going to tell you the answer. I'm going to tell you the answer. The answer is 9. It's B. All right. Let's solve this. Oops. Oh, go back. Yeah. Let me show how I solve this. Okay? All right. So alternate interior angles are equal. These are alternate interior angles right here. So assuming these are parallel lines, the alternate interior angles have to be equal. So we set them equal to each other. 9x plus 1 equals 7x minus 3. Add 21 to both sides. 9x equals 7x plus 18 because the 21 cancels out. Drop that 9x. 7x minus 3 plus 21 is 18. So 7x plus 18. Subtract 7x from both sides. 9x minus 7x is going to be 2x. 7x minus 7x cancels out. Just like 18 drops down. 2x equals 18. Divided by 2 on both sides. 2x divided by 2 is just going to be x. 18 divided by 2 is going to be 9. X equals 9. 9 is your answer. Some fire geometry. Awesome. So, Construction. In the window shown, the diamond grid pattern is constructed by hand. Is it possible to show the wood pieces that run the same direction or parallel? If so, explain how. If not, explain. Tough question. Alright. Measure the corresponding angles formed by two consecutive grid lines and the intersecting grid line traveling in the opposite direction. If these angles are congruent, then the grid lines that run in the same direction are parallel by the converse of the corresponding angles of posture. Wow. I was gonna wonder if those lines are parallel. But they were. There's only one point out we should measure. Alright. In the game of tic-tac-toe, 4 lines intersect to form a square with 4 right angles in the middle of the grid. Is it possible to prove any of the lines parallel or perpendicular? Choose the best answer. Okay, so a lot of these lines are going to be perpendicular because there's 4 right angles. But 2 horizontal lines are parallel, yes, because this is a right angle and this is a right angle, and these are supplementary. So A is definitely correct. 2 vertical lines are parallel. Alright, 2 vertical lines are parallel, yes, because this is a right angle and this is a right angle. That would be consecutive interior angles, and they're supplementary, so that would be correct. Vertical lines are perpendicular to horizontal lines, yes, because these all form right angles. All these are true. Boom. Realize I probably should ask you guys to try to solve that on your own for a little bit instead of just telling you the answer. My bad. My bad. Alright, that was the lesson for today. The lesson. Hopefully you guys learned a lot about geometry. I know I did. And join me next week for another episode. Well, actually not next week. Join me tomorrow for another episode. Join me tomorrow for another episode of Geometry with Mr. Selby. Awesome. Thank you guys. Remember to stay safe.